Hello students, in this video we'll consider tubular neighborhoods of a curve. Let's be given a curve in arc length parameter. Okay. And so let's draw this curve. Here's our curve gamma of s. And what I'm going to do at every point on this curve is I'm going to draw its Frenet-Serret frame. So there's my t, my p, and my b. Again, over here, t, p, and b. My Frenet-Serret curve. Over here, b, t, and p, like that. p, t, and b. And then I'm going to draw a circle of the same radius in the TB plane. Like that. And then connect the dots. And so what I've done now is I made a tube whose central axis is this curve, right? And so I can parameterize this, r of s and theta, by centering it on the curve, gamma of s, and then moving it r, and I'm going to have a circle in the PB plane, right? And so that's going to be r cosine theta p hat, and then plus sine theta b hat. So that parameterizes our tubular neighborhood. So this is a tubular neighborhood of gamma. Beautiful. Okay. So let's find the first fundamental form of this curve, of this surface over here. So what would my RS be? So RS is going to be t hat of s, and then plus r cosine theta, and then what's p hat? dp ds by Frenet-Serret number 2, that's negative curvature, t hat, plus torsion b hat, and then I'm r sine theta, and then db ds is negative torsion times p hat, like that. Excellent. What's my r theta going to be? My r theta is going to be what? Well, the gamma f is gone now, so we have a negative r sine theta p hat plus r cosine theta b hat. Beautiful. So what's my first fundamental form? My first fundamental form of this surface over here is going to be rs dot rs. So let's see, the coefficient of t is 1 minus r kappa cosine theta, so that's going to be squared. So in other words, so I'm using the fact that these things are t, p, and b are mutually orthogonal to each other, right? So I have t, p, and b, that's how they cross, right? And I know that they're mutually perpendicular, so I'm just going to have a 1 minus kappa r cosine theta quantity squared. Then let's see, what's the b coefficient going to be? It's going to be r tau cosine squared. So r squared tau squared cosine squared, and then r squared tau squared sine squared. So we have an r squared tau squared ds squared plus 2, the cross terms over here. So if I do the dot, I'm going to have 0 over here, 0 over here. So I'm going to have to do the, let's see, I have to do the pp. So there's going to be a, let's see, negative r tau sine theta, and then r sine theta. It's going to be r squared tau sine squared. And then the b dot b is going to be an r, right over here, r squared cosine squared tau. So it's going to be 2 r squared tau squared. Beautiful. Or just r squared, just tau maybe. Let's see, is it r squared tau? So it's going to be a, let's see, the pp is going to give me an r squared sine squared. So just a single tau over here. So just only one tau. Great. Then ds dt. And then I'll see the r, then I do theta dot theta, r theta is just going to be an r squared, d theta squared. That's my first fundamental form. Beautiful. Let's find the unit normal vector over here. So what's my unit normal vector? So I'm going to do rs cross r theta. What will that give me over here? Well, if I do t cross p is going to be b. So that's going to be a negative r sine theta b hat. If I do, and then I have an extra coefficient over here. So with my, I forgot my overall coefficient. So my coefficient of t over here is really 1 minus kappa r cosine theta t hat. Beautiful. Okay. And so what we're going to have over here is we're going to have a t cross b is going to be a t cross b is going to be a b. So this is going to be a negative r sine theta, and then 1 minus kappa r cosine theta. That's my b hat. And I can do this t cross b. T cross b is going to be negative p, right? So it's going to be a negative 1 minus kappa r cosine theta. And then this thing over here is going to be r cosine theta, and then a p hat. Great. And then what are my other terms over here going to be? So then I am going to have my r tau cosine theta b cross p with a negative sign. B cross p with a negative sign is going to be a negative tau. So that's going to be a positive. So it's going to be a positive r tau sine theta. If I do this over here and then r tau sine theta. So let's see. I also have this coefficient of in front of that cosine of theta, right? So that's going to be r cosine theta t hat. And then if I do this thing over here, if I do this p cross b, so what's going to happen over there? So I have a negative, and then I have a p cross b is t, right? So it's going to be a negative r squared tau sine theta cosine theta t hat. And so of course those t coefficients over here are going to cancel out, so they're gone. So I just found rs cross rt. Beautiful. And so we have rs cross r theta is going to be, I'm just going to pull out the common terms over here. It's going to be negative r and then 1 minus kappa r cosine theta. And then what's left over, if I pull out that r, is going to be a negative sine theta, is going to be a positive sine theta b hat. And then a positive cosine theta plus positive cosine theta b hat. Like that. Beautiful. Now, what does that tell me about my unit normal vector? My unit normal vector, therefore, is just going to be this expression over here on the interior, right, with up to this negative sign. So my n hat, therefore, this is just that's just a constant multiple, right? My n hat is going to be negative, what? Negative cosine theta p hat, negative sine theta b hat. Okay, excellent. And so now let's do ns. So what will ns be? So ns is going to be negative cosine of theta. And then Frenet-Serret is going to be negative curvature t hat plus torsion b hat. And then negative sine theta, I'm going to turn that into a positive because I know that Frenet-Serret is going to be a negative tau p hat by Frenet-Serret. What's my n theta going to be? My n theta is going to be what? My n theta is going to be a sine theta p hat and negative cosine theta b hat, like that. Excellent. So let me rewrite this in a little bit of a nicer way. So what do we have over here? So let's do this carefully. So this term over here is going to be exactly what? It's going to be kappa cosine theta t hat. And then negative, then the p hat is going to be plus tau sine theta p hat. And then negative, so that's going to be a positive, and then finally we have a negative tau cosine theta, negative tau cosine theta b hat, like that. Okay? So if I cross n, s, and n theta, what's ns cross n theta going to be? Let's do it slowly. So this is going to be what? This is going to be a, let's think about this carefully. So if I have t cross p is going to be what? T cross p is going to be b. So that's going to be a kappa cosine theta sine theta. That's going to be a b. If I do t cross b is negative p. So that's going to be a plus kappa cosine squared theta p hat. Now, p cross p is going to be 0, and then p cross b is going to be t. So I'm going to have a negative t sine tau sine theta, and then a cosine theta, like that. That's a t hat term. And then the b terms, the b cross b is going to be 0, and then so I do b cross p is going to be negative t. So I have a negative, it turns into a positive tau sine theta cosine theta t hat. And yet again, these terms over here with my t components are going to cancel out. Of course, that's because we're transverse to the curve, so those terms are gone over here. And so now what does that tell me? That tells me, let's write this out more carefully. This allows me to conclude that n hat s cross n hat theta is equal to what? Well, it's proportional to this thing over here, right? So in other words, it's equal to some number. What is that number? It's going to be equal to, well, I need a what? I would need a 1 minus kappa r cosine and r in the denominator. So if I put an r, if I put a negative r and then a 1 minus kappa r cosine theta in the denominator, right? And then if I put something else in the numerator, because I'm missing what over here? So in other words, I have an extra what? In front of my b, I just have a sine theta over here. In front of my b, I have a k cosine theta. And over here, I have a k cosine theta extra in terms of that. So if I put a k cosine theta on top, then if I multiply, then I can conclude this is rs cross r theta over here. So in other words, I have this relationship between ns cross n theta and rs cross r theta over here. Let's just make sure that works over here. So if I multiply k cosine theta by rs, that will turn into a k cosine sine, and then a what? And then a k cosine squared, p hat, good. And then of course I'll have this extra factor of what? I'll have the extra factor of this thing over here, and for the rs cross r theta, if I put it in the denominator, that will cancel everything out and put this into the right form. So that I can conclude from this that my Gaussian curvature of this surface is exactly this coefficient over here, is kappa cosine theta over negative r, and then 1 minus kappa r cosine theta over here. And so that is the formula for the Gaussian curvature. So let's write K sub Gauss over here. Gauss. And so this is the Gaussian curvature of the tubular neighborhood. So Gaussian curvature. Of the tubular neighborhood. Now it's important to realize that the Gaussian curvature of this neighborhood depends on theta, obviously. It depends on the curvature of the curve, but notice, and of course the radius, reciprocal of the radius of the circle itself. So that's what we expect to see. We expect to see the reciprocal of the radius. But now what's happening over here is that we've eliminated torsion. So the torsion has nothing to do with the overall curvature of this surface over here. And I can see that I get different points over different signs of this thing as we're sort of turning around the curve at different points of curvature on the curve over here. So this characterizes the Gaussian curvature of a tubular neighborhood. Thank you very much.